Okay, and here we are. This is number 29 on section 4.3. And this is the graph of a position function. So this is our regular y equals f of x, or in this case s of t of x. And we want to find out at approximately what time, and this is a function with respect to t. So this is time. This is our position. Okay, at approximately what time is the particle's velocity equal to 0 or the acceleration equal to 0? So this is our function. So it's going to be the velocity is the slope, so the function, the velocity will be equal to 0 when the slope is 0, or whenever I have horizontal tangents. So right there, or right there. You can see that's where we have the horizontal tangents. If I look over here, if I bring this straight down, it looks like it's a little bit to the right of 2. So if you estimated 2, that would be fine. Certainly wouldn't mark you off for that. The book says 2.2. Over here, this is pretty good. This is nailed right at 6. And this one over here looks like this is going to be a little bit to the left of 10. So they say 9.8. Kind of in that region, that would be fine. And you just take a line and bring it straight down. 10, it doesn't look like it's quite there. See, looks like we got to go a little bit left to the left of 10. All right, so that's what they say about 9.8. This is definitely 6. And this is pretty close to 2, but they do say 2.2. Okay, and when is the acceleration equal to 0? Well, the acceleration is equal to 0, remember, at the points of inflection. That's when concavity changes. That's when the second derivative is equal to 0. So we need these points of inflection. So here it's concave, definitely concave down, then it's concave up, then it's concave down. It looks like it's starting to go concave up right over here now. So right over here it's concave down, and it looks like it's beginning to turn up here. So it looks like I might have a point of inflection around there, and around there. Okay, so let's take a look first. So where's this going to change? So it looks like the concavity changes right about there, and that looks pretty close to 4. Okay, so that's where concavity changes right there, from concave down to concave up. So at 4. And then concavity changes right about here. It's pretty close to there. And that looks like that's 8. 5, 6, 7, 8. Yes. And then again, it's concave down. Now it's going to start to change the concave up. And it looks like I could say right about there. And that looks like that. I'd say, let's see, it's concave down. It's pretty straight over here. I would have a tendency, I probably said about 11.5, right about there. But the book actually gives you, they say 11. Yeah, it's pretty straight over here, so it could be anywhere along there. You could, if you said 11, 11.5, I don't think you'd be wrong, because it's pretty much straightens out, so it's hard to see actually where it makes a definite turn up there. So I think all this is kind of debatable. Anywhere in this range, it looks like the point of inflection could be anywhere in there. And I would, like I said, it looks to me like it's about there, which is about 11.5. But then the book says 11. So remember, concave down, changing, concave up, changes here, concave down, changes here, concave up. Okay. So I hope that helps.